It's an art, a sport, a hobby, mathematics. Wait, what was that last one? Yes, you heard me right. Dance and mathematics have many similarities. So hi, I'm Leland, and this is the mathematics behind ballet. But first, let's start off with some history. The ballet, as recognized today, originated during the Renaissance around 1500 in Italy. Most dance steps included small hops, slides, curtsies, and small, easy-to-do turns. These dance steps were so simple due to the amount of clothes they were wearing. Their costumes restricted them. Official terminology and vocabulary was arranged in France over the next 100 years. In the 19th century, early classical ballet started coming into play. During this period, pointe was created. Pointe is when dancers wear a special shoe with a wooden block in the toe, and they stand on their toes and dance that way. Not only was it created during this time, but it became the norm for ballet dancers. But dance is truly just different kinds of math. Dance has an abundance of geometry and physics behind it. For example, dancers make many geometric forms. Dancers create these geometric forms within their bodies going through various different types of movements. An example of that is your basic line. Dancers are usually in some sort of formation that includes lines. These lines can change and move around. Dancers can also create lines within their bodies or with other dancers. Zigzag patterns, squares, circles, curves, and figure eights can also be created. The dancer here in this picture is in grand plie, creating a rectangle with her legs. Her arms are up in a V shape, but drawing an imaginary line from palm to palm would create a triangle. And finally, if you put a line down the center of the dancer, you would see that she is indeed symmetrical. Classical ballet positions most often use elongated lines and curves, whereas modern dance includes a larger range of shapes, but all styles of dance have many different geometric shapes. We all know that a very popular dance move is turning. In Swan Lake Act 3, a dancer will do 32 consecutive fouettes. Maintaining balance, keeping good posture, and spotting can help achieve the perfect turn. Three principles in physics that are very important to successful turns are torque, rotational inertia, and angular velocity. Here we can see that torque equals distance times force. Torque is a measure of how much force acting on an object causes that object to rotate. It is basically a twisting force that causes rotation. Maintaining balance while turning can be very difficult, and that is because the laws of physics are working against them. While the dancer is trying to go up and spin, gravity pulls the dancer back down, causing her to lose her balance and fall over. Her center of gravity must be directly above the foot because it is what is in contact with the floor. The smaller the floor contact, the harder it is to stay balanced. To help maintain balance, dancers will pull up their knees as much as they can as well as their body. Doing this will lead to a successful turn. The first turn I will be talking about is a pirouette. A pirouette is a 360-degree rotation of the body around a central point on one foot. Pirouettes can be described as an act of spinning on one foot with dancer's leg in passe. A pirouette is shown in this picture here. Passe is a raised foot touching the knee of the supporting leg. When performing a pirouette, the dancer's angular momentum resides predominantly in the arms, legs, and torso. The dancer spins around a vertical axis, making the torque rise. This is given by the force and vertical distance from the line of action of the force to the rotational axis. Another turn in dance is a fouette. A fouette is a continuous turn that is done on one foot. The turn starts by the dancer being in a prep or fourth position. Then, like a pirouette, they lift their non-supporting leg up to begin the turn. At the start of the turn, the rotational inertia is small while the angular velocity is big. This turn then differs from a pirouette because the turn stops slightly in between each rotation to push off the ground and regain momentum and extends her arms and non-supporting leg. While performing a pirouette, the extension and retraction of the non-supporting leg affect the speed of the turn. When the leg is extended, she slows down, and when the leg is retracted, she'll speed up. While dancers try and perform intricate jumps, the law of physics works against them. Gravitational force plays a huge role in jumps, although gravity only influences the vertical component of jumps and not the horizontal. Dancers perform many kinds of jumps. The more massive the jump, the greater the gravitational pull. Gravitational force is proportional to the object or person's mass. Therefore, if the mass is doubled, so is the gravitational force. An example of a jump in dance is a glissade. A glissade is a movement typically used as a joining step in which one leg is brushed outward from the body, which then takes the weight while the second leg is brushed in to meet it. This jump begins in fifth position, then does a hop leg motion horizontally to land back into fifth. Having friction is very important when performing a glissade. When the dancer pushes off the floor one way, the friction between the leg and the floor creates the push in the other direction. Dance and mathematics are highly similar in the topic of patterns. Dancers use patterns for the order of their movements, spacing of dancers' formations, and much more. As the number of dancers increase in a dance ensemble, so does the number of possible ways to move them around and create lots of patterns. Pieces involving more than one dancer often use the idea of translation. Asking a group of dancers to do a movement at the same time would introduce that idea. For example, this picture here shows two parallel lines. The simplicity of this formation emphasizes proper ballet technique and the beauty of ballet. Although the choreographer may choose to put dancers in different types of formations, which can include pyramids, triangles, trapezoids, and other geometric shapes and forms. Dance and math have many similarities, and knowing the correlation between the two can help us develop a deeper understanding of them. Thank you. Are there any questions?